Now, first, let's come towards molarity. What is molarity? Molarity is the number of moles of solute which is dissolved per liter of solution. So that is called number of solute dissolved per liter of solution. That is called molarity. And 1 molar solution is one that contains 1 mole of substance in each liter of solution. It is dissolved by dissolving 1 mole of substance in the solvent and diluted to a final volume of 1 liter in a volumetric flask. Uh, for example, if we have a salt, that is of sodium chloride, for example. This formula weight will be equal to 58.5 gram per mole. Because sodium has twice mass number and chlorine has 35.5 gram per mole, that is gram per mole. So by adding this and this, we will get this one. So this is the formula weight of mass numbers formula weight of sodium chloride. For example, we have taken sodium chloride that is 2 gram, for example. 2 gram of sodium chloride has been taken. So first we will convert this gram into mole because molarity is the number of moles per liter of solutions. We have first taken 2 gram of sodium chloride dissolved, which is dissolved in 250 ml of uh, water. Now, how we will determine the molarity? How we will determine its molarity? So, point to be noted that we have taken 2 gram of sodium chloride, which is dissolved in 250 ml of water. For example, this is we have a flask here, and we have taken 2 gram of sodium chloride. That is sodium chloride. Is taken 2 gram of sodium chloride is taken, and this that is a 250 ml flask total volume. We have half. First, we have taken sodium 2 grams of sodium. Then we filled water. Then we fill water into it, half filled. That is up to this level. Now shake, shake well the flask. Shake well this flask. When the 2 gram of sodium chloride is completely dissolved, then make up the volume uh, up to this mark. So you can say that fill up to this mark. So this is 250 ml flask. So now this solution in this solution we have taken uh, 2 gram of 2 gram per 250 ml. Now how we will determine its molarity? I can say that which molar solution is formed in this case. So now let's come towards, first we will convert this 2 gram into moles, 2 gram into moles, because we know that 2 gram of sodium chloride, that is sodium chloride, and formula weight of sodium chloride is 58.5 gram per mole. So this unit that is also sodium chloride. So this unit and this unit of gram of sodium chloride is the same. So we can cancel this one. So from this so uh, in this case, Grom and Grom finish here will cancel each other, and we will get the result here point zero point zero. We can write here point zero 342 342 mole. We have obtained point 0.0342 mole of sodium chloride. So after getting the moles of sodium chloride, uh, point 0.0342 mole of sodium chloride we obtain. After turning moles of sodium chloride, we can just divide 0.0342 mole of sodium chloride uh, because we have dissolved this mole in 300 or 250 ml of let's say that 250 ml of water. So in this case, we can say that uh, so here we will get the result. So we will get the result 0.001368 0.000138 mole per ml. That is unit mole per ml, and we need mole per liter. So we will convert this mole per liter into mole per ml into mole per liter. So how we will convert this mole per ml into mole per liter? We should simply multiply this figure into 1000 in the way like this. So point 0001 is 608 uh, mole per ml into we can say that here 0.000138 mole per ml because we know that 1000 ml is equal to 1 liter. So 1000 ml will be equal to 1 liter. Ml in this case will be cancelled with each other, and we will get uh, here the value 0.000138. We will get the value 0.001368 mole into thousand mole per liter, because this liter remaining and this mole remaining, so we'll get here mole per liter. If we multiply this, in this case, this unit, well, point 1368 mole per liter, which is equal to molar. So the solutions we have met by dissolving 2 gram of sodium chloride in 250 ml of water. So from this we have formed 0.1368 molar solution of sodium chloride. So this is the all about the molarity of sodium chloride. You can also produce another salt. So in the same case, example number 2 of molarity. Example number 2. For example, we want to calculate the molarity of solution of NaOH solution uh, we have taken uh, solutions by dissolving a 0.59 gram in 3.59 gram of NaOH, which is dissolved in 300 ml of 300 ml 300 ml uh, of solution. So how we will determine its molarity? So in the first example, we have learned that how we will calculate the molarity of a solution. So in the same case, we also can determine the molarity of sodium hydroxide or sodium nitrate or any salt in the same way. So we know that molarity is equal to number of moles of solute per liter of solutions. So here we have 0.59 gram of NaOH, and we will convert this gram first into mole and then ml into liter. So when we get these two values, mole and liter, we can simply calculate the molarity of the solutions. So here it is a point 0.59 gram, 0.59 gram of NaOH. Or we know that for molar weight of NaOH is equal to 40 40 gram per mole. So in the same case, we have 40 gram of NaOH per mole of NaOH. This unit is same, so it will cancel from with each other, and we will get 0.59 mole, 0.59 uh, divided by 40 mole of NaOH. We will get this one. So here we know that we have the unit mole and we require mole per liter. So we have dissolved 0.59 gram of 0.59 uh, divided by 40 mole. We know that we have dissolved 0.59 gram in 300 ml. 300 ml divided by mole into 300 ml. So in this case, we will get a unit mole per ml, and we need mole per liter. So we will simply multiply this with 1000 as in previous example we have seen, and by producing this we will get 0.59 divided by 40 mole into 1 divided by 300 ml. So we will get we will get if we will also convert the ml into liter. So we will multiply with 1000, same 1000 ml will be equal to 1 liter. So ml unit will cancel each other, and in this case we will get 0.0 we will get 0.59 divided by 40 into 1 by 300 into 1000 mole, this one, per liter, this one. So we will get this unit which is also called molarity. Molarity is also called molarity. By multi multiplying and dividing these figures, we will get 0.05 molar solution of sodium hydroxide. So this is called 0.05 molar solution of, we have made zero point zero 0.05 in the solution of sodium hydroxide. So in this case, he obtained the molarity of sodium hydroxide, which is 0.05 molar. Now let's come towards normality of solution. What is normality? Normality is similar to molarity, except normality utilizes a quantity of chemical called equivalence rather than moles. So here we can say that normality uses a quantity which is called equivalent rather than mole. Rather than mole. So in normality, we will use equivalent instead of mole because we know that molarity is equal to per moles per liter, and normality will be equal to equivalence per liter. So instead of mole, we used equivalent. So this is the difference between molarity and normality. This is the difference between the two. Uh, for example, if two equivalent dissolved per liter, if we have two equivalent which is dissolved per liter, then the solution will be 2 normal. The equivalent is the same as the mole or some fraction of mole. Equivalent is the same as a mole or fraction of mole, uh, depending on reaction involved. Depending on reaction involved, depending upon the reaction takes place. Equivalent weight uh, is the same as a formula weight or some fractions of the formula weight. Normality is the same as a molarity or some multiple of molarity. For example, in acid-base neutralization reactions, the equivalent of acid in acid-base reactions, the formula weight dissolved by the number of hydrogen lost per formula of the acid in the reaction. So here we have noted the formula weight divided by the number of hydrogen lost. The formula in normality cases, we have seen that we will get formula weight divided by number of hydrogen lost. Lost. Number of hydrogen lost per formula of the acid in the reactions. So acid may lose one or more hydrogen when reacting with the base. Acid may lose one or more hydrogen when reacting with the base. Acid may lose one or more hydrogens when reacting with the base. For example, HC, the reaction between acid and base. Acid is HCl plus sodium hydroxide, which is a base, and it will produce sodium chloride, this is salt, and water. So here, this is an acid, this is a base, this is acid, this is a base, and this is a salt produced, and this is the water, liquid. So here we have noted that one hydrogen, one hydrogen is lost, and which is that one. One hydrogen is lost. So only one hydrogen lost by HCl. HCl has lost one hydrogen, and by the reaction of HCl, eventually we get sodium chloride in the water. But in case of sulfuric acid, H2SO4 plus, we can say here that we in case of sulfuric acid H2SO4 plus uh, NaOH. Same case, we'll get Na2SO4 plus H2O. So, in order to balance the chemical equation, we will put 2 here and we will put also 2 here with water. So, here 2 hydrogen is lost by 2 hydrogen is lost by sulfuric acid. 2 hydrogen is lost by sulfuric acid. So the equivalent of HCl is the same as the formula weight. The equivalent of HCl is the same as the formula weight, which is equal to HCl, which is 1 plus 35.5, which is equal to 36.5. So that is the equivalent of gram per mole. Gram per mole. While in case of sulfuric acid, it has half the equivalent weight of formula weight. Half equivalent weight to the formula weight. For example, we know that S case of sulfuric acid is to SO4, which is 2 hydrogens plus sulfur is 32 plus oxygen is 4, so we multiply solar charge on set Sol 64. In this case, we'll get to 98. 98. So in this case, 98 is the formula weight of sulfuric acid. If but the formula weight is not the same to that of equivalent weight. Is in case of HCl, which has both formula weight and equivalent weight the same. But in case of sulfuric acid, equivalent weight is half to that of formula weight, which is 92 divided by 2, and that will be equal to 49. For example, for example, for example, if we want the normality of sulfuric acid, and we have 0.248 moles, which is dissolved, in 250 ml solution. So we have seen that we have 0.248 moles dissolved in 250 ml of solution. So if we determine the normality of sulfuric acid, we know that normality is equal to moles of solute, to equivalent per mole divided by liter of solution. Liter of liter of solutions. So that will be equal to that will be equal to 0.248 mole. There are 2 multiplied by 2 equivalent per mole divided by the volume, which is 250 ml, and that will be equal to 2.250 liter. So we will get here 1.98 equivalent per liter. So the normality of sulfuric acid is 1.98 equivalent per liter.